There's some huge benefits to unit testing, the main one being that it is super fast. It's simply much more robust than end-to-end testing because you don't have the weird robot interface or whatever. You're directly interacting with your components. And the other thing is that when something breaks, it's telling you fairly precisely where that problem is taking place. So some tools here. Straight up Mocha, we're going to talk about, like we talked about this in the panel, this is going to be Mocha with no Meteor test or anything. It's just straight from NPM. And then we're going to use a library called testdouble. The inspiration for doing this is a post that was done by Pete Corey. I wanted to give a quick shout out to him, and he gives some shout outs to other people in his article. This post will help you to set up something like this if this interests you. So definitely pay attention to that. And you can find it by unit testing with testdouble will get you to the right place if you Google search it. So let's go to a demo. All right, so we're mirrored, good. All right then, let's see here. I think one thing I'll just do real quickly, well, no, let's look at the code real quick. All right, so I want to show you like kind of a dumb, this is kind of a dumb unit test. Let me describe what's happening here. We're importing a function called createStars, which is all it's doing is so the app we were looking at talks to Foursquare, and it pulls down information about locations in there. And there's a rating on Foursquare, which is, say, a rating of like 0 to 10. And we want to map it to a 5-star rating system. So all we're going to do is we're going to divide by 2 and round it. That's actually what we're testing. So it's a pretty trivial thing to test, but I want to show you like what you can do with unit testing. So you can see like we could pass in, you could think like, well, if I pass it 0, it should return 0. If I pass it 2, it should return 1. If I pass it 4, it should return 2. This is the obvious path. And in unit testing, you can test them all because it's fast and you don't have to worry about it, and it's very exhaustive. And then you can try the odd numbers, and you can try the almost odd numbers, and then you can try even like weird numbers. What happens if I pass it minus 10,000? What will it do? What happens if I pass it undefined? Here it is. Here's undefined. What happens if I pass it a random thing that is not even related to what I'm getting? Do I want it to fail gracefully, or do I want it to throw an error? You can test for either one. So when you do that, you probably not. Oh, it's going to be like impossible to. Is my text too small? I didn't even like. No one said that they needed it bigger. Is the text on the code, is it big enough to read? Okay. All right. So I'm going to switch to a new tab here, and I'm going to run npm. Oh, I need to make it bigger again. npm run unit test, and I'm going to have it run in watch mode. So, okay, there we go. We ran all the tests. It took 94 milliseconds. So it took less than a second to run more tests than we ran in the end-to-end test. This is like one of the primary advantages. So like if I take this result and I ask for the wrong thing, which will make it cause an error. Oops, I always do that. I always hit enter. Hit save. Okay, I immediately got an error back. I hit save again, and I get the clean result back. So these tests are lightning fast, and when you can do a whole bunch of them, and it'll still only add up to a few seconds of testing. That is one of the primary advantages of unit testing. Now, you can see like in my code, this is something you can do in these assertion libraries, is you can pass like a little hint. Like here I say I passed hello. If I break that code, then I can see in the error that it will pass me that information. You can add in like what was passed or what the result was, so that it helps you to understand what went wrong. And I think that's all I want to show you from that. Let's look at something that's a little bit trickier. Let me see, so in the Foursquare API, you can see that, okay, first of all, I'm doing an HTTP call to like pick up some information from Foursquare. And then once I get that information, this is called get Foursquare places. Then I have a get filtered Foursquare places. That's a very, very verbose but descriptive, hopefully, where it's going to do some stuff with that, and it's going to filter that information and make calls against that. But notice all these imports I have: eJSON, Meteor, HTTP, check. So all of these things create stars. I need actually one more of my test files down here. Hold on. Oh no, maybe I have it already. So here we go. Let me close that up. So that could cause a problem for me. If I let me show you what happens if I don't do the solution that I'm going to show you. This is the error that you will find if you just try to implement unit tests without some kind of test double solution. You will get this error of cannot find module Meteor/Meteor. There's a very good reason for this, which is because there is some magic in Meteor 1.3 that wires Meteor/Meteor to the Meteor package system. So if you're running Meteor, then this will resolve to the actual Meteor package in the Meteor package system, and this happens for all of the packages that you need. If you're running straight up Mocha, you're just using npm, and npm doesn't know that about your code. Therefore, it freaks out and says that module doesn't exist. So the solution is, and this is the thing that from the Pete Corey article that I showed you, is that you want to have test doubles. You're basically going to stub out Meteor. So we have this, so TD is a test double that I imported higher in the file, and I'm just going to replace Meteor and HTTP and eJSON and check and underscore with these kind of fakey objects. And in many cases, like Meteor doesn't even need to be a real thing because we're not using any Meteor methods. We just need to make sure it doesn't error out when we import it. And so we stub those out, and then we are able to run our code. And so like, what is this? Let's see if so I made a Meteor double here that so I guess maybe we called Meteor publish, but I don't even care about that, so I just made it an empty function. And I put in a couple of settings that I don't care about that make it error out. So you replace those things, and once you do that, then your code will run. And so here's some code right here where I wanted to see if the filter was working correctly. And in the original code, the filter calls Foursquare for each category that you want. So if there are no filters applied, it should call all of the categories. Now I've set up some dummy data somewhere in here. I'm going right past it. Or is it down below? There's some dummy data that have categories 1, 2, 3, and 4 that should be returned. Oh, here it is. Here's my categories, sorry. So I don't have to use, the real categories data is more complete. There's a lot more things in it, but we don't need that for our testing. So we made a very simple thing, and we decided that if we had no filters, we wanted all of those to be included. That meant we had to call the Foursquare API 4 times. And so what we did is we stubbed out get Foursquare places, and we just verified that it got called. So we don't have to make that. We saw that HTTP call that we had in that function. We bypassed that, and we just make sure that we asked for the thing that we wanted. So the Foursquare API is not being tested. We're trusting Foursquare to return the right data. But we are able to check that our filter works the way it should. So that in this case, each one of the filters gets called one time. But if we then set the filter to have one of the filters, one of the things set, it's going to return only that one that we selected and not the other ones. So I think that will do it for, there's one other thing that I wanted to show you. So creating these objects that are these Meteor fakes is kind of a pain. So I'm thinking I have an idea for an NPM package that right now is not not published, but I think it might be useful. So if this is something that interests you, you can talk to me afterwards. But I have this idea for a Meteor test doubles package. And the idea is that, let me show you the usage of it. So you would what you do is, so you have this Meteor test doubles package, and then you can import Meteor and Mongo and things like new collection, which would be if you called new mongo.collection from Meteor test doubles, and then you could replace, for example, your collection with an instance of new collection, and then if you look at what new collection gives you, it gives you the Mongo API, and it does it with test double, so you can actually tell if you want to test to see if your collection had find called on it, you can do that. So if we had this for the entire Meteor API, then without much effort, you could stub out all of Meteor and do unit tests with these super fast tests without having to put in all the effort of figuring out how to do that. So, I think that's it for the demo. And what I can say about this from having done this is that unit testing will change how you code. We're pretty used to, in Meteor land, we're used to having lots of anonymous functions that may be helpers, they're things that you pass to parts of Meteor to make your code work. And sometimes, either you want those to be it'll teach you to make those very minimal so that you don't need to test them, or it'll teach you to turn them into named functions so that you can export them and test them individually. So you'll have smaller functions, you'll have fewer dependencies. In other words, you'll write better code. But as you saw, it's a lot more involved. There's a little bit more mental work in order to get this working. You have to stub out libraries, including Meteor itself, and you have to learn how to isolate functions. One thing I will say about this is the question that I was asking to Ben earlier, is that you need to set up a Babel RC file. And there's one that's indicated in Pete Corey's article. This is a different one that Ben indicated was a little bit better. It's a little bit closer to the way Meteor does its compilation. Now, if you put this in your root directory, it will actually tell Meteor to follow this method. So you'll actually be changing how your real app compiles, which means that there's a couple of quirks in it that you will have to follow in your actual real app in order for this to work, which includes not being able to use absolute paths in your imports, and not being able to use import statements in nested, inside functions and if statements. And so that's a price you have to pay if you want to follow this model right now. It's something that I would love to eliminate from this, but for now, that's how it works, and I think it's worth it in order to have super fast tests. So that's it for demo tests. On to recommendations. So what about Meteor Test? This is a function that is now available to us that I didn't even talk about. Well, first of all, it's a totally viable option for unit tests. It will give you perfect Babel compilation. You don't have to use a Babel RC file. You don't really have to think about all that stuff. But you will pay the price of having Meteor start up and having Mongo start up every time you want to run unit tests. So you will not get the speed that I was talking about.